Good morning, dear professor and faculty members. This is my homework for number one with the topics of DH parameter. We are gonna solve Denavit Hartenberg parameter for 3 degree of freedom RPR manipulator, revolute, prismatic, and revolute manipulator. This is the original image of the robot. So, before we dive into the exercise, we have to know DH parameter first. The Denavit Hartenberg parameters are systematic way to represent the kinematic structure of a robot manipulator using 4 parameters per joint. They are commonly used in robotics and kinematics to describe the relative motion between consecutive links. It's going to be 3 steps to solve the Denavit Hartenberg parameter to find the homogeneous transformation. The first one, draw the kinematics diagrams according to the 4 Denavit Hartenberg rules. The 4 Denavit DH rules, well, we will talk about it later. And the second step is create the Denavit Hartenberg parameter table. And we have to be cautious because there are uh, two rules that we have to follow. The number of rows equals to number of frames minus 1, and the number of column, of course, will be 4. 2 column for rotation and 2 column for displacement. And the third one, find the homogeneous transformation matrices. This is the 3 steps to find the Denavit Hartenberg parameters. Okay, this is the 4 variables. This is the 4 variables that from the first step that we have to obey. Uh, this is what we are talking about is we have to find this table. This is the join. This is the theta with degree, and this is the alpha degree, and this is the Ri in centimeters and Di in centimeters. Okay, let me. Okay. The theta is the angle from xn minus 1 to xn around zn minus 1. What is n? N is the frame. So if this is the current frame that we analyze, and then this is the n minus 1. Let's see the theta. Let's see the theta. Theta, how to, first we have also to know how to define the, what is it? The frame, define the frame, the axis of the frame. The first one, we have to define if this one is, for example, like this one. This is the revolute joint. So if I assume that the axis of the motor is going to be that way, then I have to define that the axis of the motor is going to be the z-axis. So in this case, this is the z-axis. And after that, we have to follow the simple right-hand rules. I find this z-axis is going to be my thumbs, and then After that, I define the x-axis. I define the x-axis. X-axis is going to be my four other fingers in that direction. So where is the y direction? This is the z direction. This is the x direction. So the y direction is going to be that way. Okay. And to define the direction of the motor, we can directly like this. If this is the z axis, the direction of the motor is going to be like this. Same as my four other fingers going to point. Okay, that's the example of how to define using the right hand rules. So the theta is the angle from xn minus 1 to xn. So this is the xn minus 1 to xn around the z-axis, around this axis. So what we call as theta is this one. In this case, because the xn minus 1 and xn is on the same direction, so the theta is the same, so 0. And alpha, the second variables, alpha is the angle from the cn minus 1 to cn around xn. cn minus 1 to cn around xn. Okay, because and we know that xn minus 1 and zn minus 1 and zn is in the same direction, and the so in this case the alpha is going to be a 0 also. After third variable is r. Sometimes it's called as a, sometimes it's called as a, and sometimes the others define it as r. R is the distance between the origin of the n-1 frame, n-1 frame, and the uh, origin of the n frame along the xn direction. So this is the origin, n-1 frame. This is the origin, n frame, and this is the distance between it. We call it as r. And what is d? The fourth variables. D is the distance from xn minus 1 to xn along the zn minus 1 direction. Okay, this is D. Distance from xn to xn minus 1 to xn along the zn minus 1 direction. So this one is D. This is xn minus 1, this is xn, and the distance between it is t. That's how we define the theta, alpha, r, and t. The first step, this is the exercise that we are going to analyze. I think this is something wrong with this one, because if the direction of the theta should be from behind, because if the axis of the motor is gonna be upward, we are using right hand rules. The direction is uh, reverse compared to this one. This one is also okay. In my case, my frame is gonna be like this one. This is revolute with theta 1 as this one, and this is the prismatic with the displacement up and down, and this is the third joint is same with this one, and this is the n effector. Okay, after I draw the frame, and then the second step, create the DH table. Okay, this is the joint. First, we find the theta in degree. Theta is the angle from xn minus 1 to xn around zn minus 1. For example, this one. This one is x1, this one is x2. So, joint 1 is from the x1 and x2, frame 1 to frame 2. The x1 and x2 are oriented in the same direction, meaning the axes are aligned. As the robot moves, theta 1 will change, causing the robot, the frame 1, to shift. The angle x1 to x2 around z is given by theta 1. So this one is the same. This is theta 1. So the direction, if this one is rotating, this one is also rotating, and the rotation in degree is defined as theta 1. And for the joint 2, from this one, both x2 and x3 are oriented in the same direction, meaning the axes are aligned. When the robot is in motion, there is only linear motion along C2, only up and down. So the angle from x2 to x3 around Z2 will remain 0 because it's going to be the same as always. And from this one, x3 to x4 is the same because if it will rotate, this one will also rotate. So the angle of from x3 to x4 is going to be the theta. It's going to be x3, and we find the alpha. The second parameter, alpha is the angle Zn minus 1 to Zn around Xn. Alpha, alpha 1, let's find it alpha 1. Alpha 1, Zn, Z1 to Z2 around X. This is the same, so the degree will be 0. This one is also the same, so the degree will be 0, and this one is also. And we have to find the R. R is the distance between the origin of the n-1 frame and the origin of n frame along the xn direction. This is the origin, this one. The length of this one is 0 because this one is prismatic, and the origin of this one and this one is going to be the same. There is no change in it. In the x direction, because in the x direction this one is in the one frame, so the value of R1 is 0. But compared to this one, the origin of this one and this one, the length of it, it's gonna be L2. So we put L2 in here. and this one to this one, the distance of it is going to be L3. And the last parameter is the D. D is the distance from xn minus 1 to xn along the set n minus 1 direction. Xn to x2 along the c n minus 1 direction. This should be the length of it should be L1, but because there is a displacement prismatic, so we have to remind that the D2, this defined predefined variable, we have to mention it on the table. The length of it plus G2, because this is the displacement. And on the x2 to x3 along the z direction, it's in the same level. Even though this one is going down, this is on the same level. So it will be 0 centimeters. In this case, also the same. So this is our DH parameter table. After that, we have to make the assumption. This table is based on this assumption. All z-axes are aligned and pointing upwards. Alpha I always 0 for all joints. And prismatic joint 2, this one, contributes a variable displacement d1, so d1 for this one, equals to L1 plus d2. And revolute joints, joint 1 and joint 3, rotate around C but do not change in D. Okay, the third step is gonna homogeneous matrices. This is the template for homogeneous matrices. C is for cos and S is for sinus. So for this one, this is the from the joint I to J, homogeneous matrices for transformation matrix from I to J. It's gonna be cos theta I minus sin theta I cos alpha I and so on. So based on this one, this is the template. This is from the frame 1 to frame 2. So we have to put from the equation here. C theta 1 and minus sine theta 1 cosine alpha I is degree. So if cos 0 is 1, so we only wrote this one minus sine theta 1. For this one, sine theta 1 multiplied by sine alpha 1, sine 0 is going to be 0, so sine theta 1 multiplied by 0 is going to be 0, and so on. This is transformation matrix from frame 1 to 2, and this is from frame 2 to 3. We have this kind of stuff, and this is the frame 3 to frame 4 TNF factors. And this is the summary of all transformation matrices from T1 transformation matrix from 1 to 4, frame 1 to 4. It's all the multiplication from frame 1 to 2, frame 2 to 3, from 3 to 4. We summarize as this one. This is the forward kinematics of homogeneous transformation of this RPR robot. For this RPR robot, the reference that I use the edition Sir Collins from Automatic Edition. This is all that I can present for these topics. The Denavit Hartenberg parameter of 3 DOF revolute prismatic revolute manipulator. Thank you so much for your kind attention and see you on the last video.